Today I'm going to be reforging a regular 4-pound sledgehammer into a 4-pound crosspeen. Hi, I'm Dennis Frechette and welcome back. Today I'm going to be taking a 4-pound sledgehammer that I found while I was cleaning up, and I'm going to turn it into a crosspeen. I've been needing a 4-pound crosspeen, but I didn't have a hammer that I could, reshape into one, so I've been kind of holding off on this project, but I have it now, so that'll give me a 2.5-pound crosspeen, 3.5-pound crosspeen, now a 4-pound, and then I have my 5-pound crosspeen, which is a little bit too heavy for me now. I still use it every once in a while, but you run out of gas pretty fast when you're using that. So that's what I have for you today, and hope it helps you out. This is the hammer that I'm going to be working with today. It's just a standard 4-pound sledgehammer, and I'm going to be reforging one of the faces into a crosspeen. I'm also going to be replacing this narrow handle with something that has a wider cross section. When I start my fire, I usually compress the coke over to the back side of the fire pot. That allows me to get my torch right down at the base of the fire. So I get the fire going from the bottom up. I just heat up the coals, wait till they get established, give it a little bit of air, and when I see that the coals are going to take the air, then I just push more coke into the other side of the fire pot, and I automatically have a fire going underneath of all of the coke, so it gets established very quickly. Once I have my fire going, I just set the hammer on top of the pile of coke that's burning, and then I pile more coke around the hammerhead, and then I pack raw coal around that and get that ready for the next batch that I'm going to need in the center of the fire. This is the slowest part of the whole process. Forging the hammerhead only takes a few minutes, but I'm going to need to keep this hammer in the fire for a minimum of half an hour to 45 minutes to make sure that I have a good solid heat all the way through the whole billet. Now, a lot of people starting out have the idea that you need to be standing by the fire and watching it the entire time, but that isn't the case at all. I've said it in other videos, and it certainly applies here. You get the fire going, establish it, make sure that it's really has a good head of steam ahead of it, pack in a heavy bar like this in some coals, and then just walk away from it for a while. Come back, check on it, see how it's doing, give it a little more air, adjust it, tighten up the fire, whatever you need to do, and then walk away from it for a while. What you want to do is establish kind of a blood red to a bright red heat in the bar, and you just want that to sit there for a good 15 or 20 minutes. Let that soak right into the center of the bar, and then once you've established that heat through the bar, then you can start raising the temperature of your fire and bring the bar along with it. So you just give it some air, raise the temperature of the fire, make sure that's well established, walk away from it, do something else in the shop, get something else ready, whatever you have to do, come back and check on it. You'll find that once the billet gets hot, it actually starts to drive the fire. So your fire isn't going to cool off as fast as if you have 4 pounds of cold metal sitting in there. So you'll be able to start raising the temperature of the fire because the billet is going to give the fire a certain amount of momentum to maintain that heat. So you just start slowly raising it up to the forging temperature. Again, you don't have to get excited about the whole thing. The key is always get the fire to the temperature that you want your forging to be, and then let the piece of steel catch up to the temperature of the fire. And when that happens, you take it out and start forging. I'm getting ready to forge the hammerhead, and you'll notice today that I have a little bit of help. This is Brian. He's been working with me for about a year and a half now. We both have pretty busy schedules, so sometimes it gets hard to line stuff up. But fortunately for me today, he was able to stop by and give me a hand with the hammering. So he's doing the sledgehammer work, and I'm basically just standing around and watching things happen. So as you can see, the forging isn't too complicated. You're basically just flattening the one end down to a cross peen shape. We did have a little bit of a fish mouth at the end of the billet, but that's pretty hard to avoid when you're moving that much material right next to a square cut end like that. Once the forging is done, you can go ahead and grind the hammerhead to its final profile. Next, you need to reheat the bar to critical to get it ready for the quench. This clip is actually from the initial heating of the bar when I was getting it ready for forging, but the process is exactly the same. I start by establishing a really dull red in the bar and letting that soak for several minutes until I'm sure that that color is right through the entire cross section. And then I slowly bring it up to critical and quench it. Here I'm quenching in canola oil, and I'm leaving the bar submerged until it's cold. This is a pretty big bar of steel, and it's going to take a long time to cool down, so just leave it in the oil until you see all the bubbling and the activity around the bar has stopped. And when you pull it out from the oil, make sure that it's not smoking. Put it back in, let it get cold. Also, a 4-pound hammer is probably the most that I would do in a bucket of oil this size. When I was done with this hammer, the outside of the pail was quite warm to the touch, so I wouldn't try quenching anything else in this oil for at least several hours, and I would probably leave it till the next day before I tried quenching another hammer this size. If you try to quench too many items at a time, the oil is just going to keep getting hotter and hotter and eventually reach its flash point, and then you have a pretty difficult fire to deal with. So with this setup that I have here, I have a plastic pail which is giving me the watertight container that I need for the oil, and then I have that in a metal garbage can with a fairly tight fitting lid. So if I ever do run into problems, I have the option of putting the lid on this, and I have handles on the outside of this can where I can get the whole thing out of the building. I tempered this hammer to a dark straw, which is about 425 degrees in our oven, and I let it sit there for about 3 hours. Anytime that I reforge or I need to put a new hammer handle onto a hammer, I always regrind the eye because all commercially made hammers have an eye that is hourglass shaped on all 4 sides of the eye. And I prefer the sides of my hammer handle to be the full thickness of the stock that I'm using for the handle. So before I fit my handle, I take the time to grind away the hourglass shape all the way around the eye so that all of the sides of the eye have parallel straight sides. And then I reestablish a bevel on the front and back of the top side of the eye. If you have a die grinder, you can do this at any time. I usually do it first just to get it out of the way, but if you don't have a die grinder, you need to use a file, then you will need to do it after the forging and before the heat treating process. Having the eye of the hammer configured this way means that you're going to be able to get a very good tight fit along the sides of the hammer simply by driving the hammer handle in place. You won't need any wedges. And the only wedging that you're going to need to do is to spread the hammer handle along the length of the eye, so front and back. I tried shaping this handle with a draw knife the way I normally do, but the grain was so twisted and interwoven and just plain squirrely, so I couldn't get a clean shaving with anything that I tried. So I'm going to fast forward and head over to the belt sander and get it done that way. So I'm a little further along here, and all I need to do now is to saw in the cuts that I need for the wedges and basically drive everything together.